All right, so in this video, I'm going to go over some empirical rule and Chebyshev theorem. I had a few questions about that. So what I've done is I've cut and pasted some examples from Hawk's Learning, and I've got my empirical rule information here, and we're just going to go through a few of these. Okay. All right, so let's start off with this question here. Okay. So it says, suppose that shoe sizes of American women have a bell-shaped distribution with a mean of 8.04 and a standard deviation of 1.52. Let's work calculator. All right, using the empirical rule, what percentage of American women have shoe sizes that are less than 12.6? Please do not round your answer. Okay, so let's draw a curve. All right, my mean is 8.04. All right, what I'm going to do is I'm going to add 1.52 until I get to 12.6. All right, so my first standard deviation away is 9.56. All right, then I'm going to add it again. And I get 11.08. And then I'm going to add it again. And I'll get 12.60. All right. Okay, now I'm going to go up here and look for a keyword. It says less than this number. So now I need to find the percentage from 12.6, all of this over to the left. Okay. Now I know using my empirical rule between 3 standard deviations in each direction, that's 99.7% of the data. Okay, but here's the deal: 1, 2, 3 standard deviations this way. If my answer is 99.7%, then that's just this part right here, and it's not including this little chunk of the curve that is less than 3 standard deviations away. Okay, so that area, if I do 100 minus 99.7, because 100% of the curve is all of the curve. Okay, I will get 0.3. Well, then I got to take 0.3 and I'm going to divide that by 2. And I get 0.15. And I'm going to divide it by 2 because there's 2 sections. There's this section down here that has an area of 0.15. And this section over here above 12.6, that also has an area of 0.15. Okay, so my final answer needs to be 99.7 plus that little tidbit over there, the 0.15%. So my answer would be 99.85%. Okay. All right, next question. I'm going to do all the empirical rule questions first, and then we'll do the Chebyshev questions next. So let me move this guy over here to these questions. All right. Nope, that's another Chebyshev. Okay, suppose IQ scores have a bell-shaped mean distribution with a mean of 95, standard deviation of 18. Using the empirical rule, what percentage of IQ scores are greater than 149? Okay, so here's my bell curve, 95 in the middle. Standard deviation is 18, so I'm going to just add 18 to 95 until I get to 149. Okay, now let's look for a keyword. It says greater than. All right, so now I need the area to the right of 149 and not all of this right here. Okay, so that would be that 0.15 area that we talked about in just that previous problem. And that's the correct answer. Okay, because 1, 2, 3 standard deviations away, I know that 1, 2, 3 standard deviations away, this middle chunk right here is 99.7%. That's 0.15, and this little chunk right here is also 0.15 for 100% of data. Okay. All right. Whoops. Let's see. Next question. All right, suppose that grade point averages of undergraduate students at one university have a bell-shaped distribution with a mean of 2.54, standard deviation of 0.42. Using the empirical rule, what percentage of students have a grade point average that are less than 3.8? Okay, so this is really similar to the very first question in this video. All right, so 2.54. So I'm going to add, let's see, 0.42, the standard deviation. Until I get to that 3.8 number that I'm looking for, okay? So I can kind of locate it. Now, keyword here is less than, so I want all of the area to the left of that number. So I basically just don't want this little area of 0.15 over here. Okay, so I could do 100 minus 0.15, which would be the 99.85, or I could think about it as the 99.7 plus 0.15. Either way, I'll get 99.85 as my answer. Okay. All right, now let's go back and do these two problems here. So Chebyshev theorem, just a little note over here, if k equals 2, that means the standard deviation, that means we're 2 standard deviations away from the mean. That's 75% of our data. If k equals 3, then that is 88.9% of the data, okay? All right, so this problem says, suppose that quiz scores in a beginning statistics class have a mean of 7.1 with a standard deviation of 0.4. State the range in which at least 75% of the data will reside. Okay, so we have 7.1 in the middle. I need to add 2 standard deviations. And then I need to subtract 2 standard deviations. Oh, excuse me, 7.1. And I get 6.3, sorry. Okay, so that'll be my range, 6.3 to 7.9. I just need to be 2 standard deviations away because 75% is associated when we're 2 standard deviations away from the mean, okay? And I think this next question is set up pretty similarly. So let's see. We have a mean of 3.55. There's our standard deviation. I want to know 75%. So I'm going to take 3.55 and I'm going to add 0.14 2 times. 3.83, yeah. And then I'm going to subtract it. $3.27. So that would be my range. Okay, and if this problem gave me 88.9%, I would have to do it a 3rd time for each of these to get my answer. Okay.